So, is there any questions for from last week? No, everybody got through it all right. I noticed a couple of you guys had issues with the turning stuff, so it just remind you. I don't. Question was it?
Lab they said at the very end that I wanted us to turn in the picture to you.
Yeah, the Google. So take a snap, like a screenshot of the Google Earth.
Oh, a screenshot.
Yeah, like a screenshot of your Google Earth image that you get with the pin locations of your flags and lawns. That makes sense.
Yeah.
All right.
When I see my Google Earth image, it wouldn't attach the image to the lab work, so I assume it's just like a PDF. Is that fine?
Yeah, that's fine. Yeah, that's not good.
I bet you a strange person. I get a signature on something.
Signature for
A class change. Someone by accident put me into a class I did not have the prerequisites for. They put me on the online plane spraying class, and I need to be hired by some group that I'm not even hired to.
Okay.
Don't know how they made that mistake.
What's
So,
your name?
Raphael.
Okay. Do you have the sheet on you right there?
I do. And a pen.
Yeah, you got a pen.
Sorry about this and interrupting your class.
No, you're okay.
I think so.
How do you hear for this?
All right, guys. So I'm going to be skipping ahead a couple labs today. Reason being is I'm not going to be here the next 2 weeks for lab, so we will have what we call an office lab for those next 2 weeks. So today, and being that the weather is going to be fairly nice, we'll just do what we call the profile lab. Usually we do this one on the week 4, but we can click into it right now and then get going. And then the next 2 labs, I'll just have a couple instructional videos that I'll upload to Canvas, and you guys can get through those with labs 2 and 3. Again, they're fairly straightforward for those 2 labs. It's all just laptop or iPad type style. This one is we're gonna be outside. We're gonna be doing a differential leveling, and let me pull up a couple things for you guys so you can see images of, and we'll go from there. Let's see here. Back to Mass Drive. No, lecture. So 2, 3. Information notes. There we go. All right, cool. So what have you guys gone over in lecture so far? Somebody just shout it out.
I don't think you posted the week 2 lecture.
Yeah, there's no week 2 yet.
Oh, you guys don't have a week 2 yet?
No.
I haven't learned anything.
What have you guys covered so far though?
Kind of just intro stuff.
All intro?
Units of measurement.
Gotcha. Okay. Let's see. Sheet 2, yeah, that's profile. Okay. Let's do a sketch here. No, that's profile. I didn't want that. Example 1. Oh, that's the same thing. Oh, no. Perfect. All right, guys. So differential leveling is what we're going to be working on today. I'll pull up a little small slideshow, but essentially, in summary, just to give you guys a quick abstract of it, it is transferring elevations from a known elevation source. Okay, so that's all we're doing today. We're grabbing a known elevation off a known benchmark or established control point, whatever we have, and we are transferring from that benchmark, and we are establishing elevations for other temporary benchmarks or benchmarks that you are using on a project. All right, and then we are coming back to that same starting benchmark to verify our tolerances. Does that make sense? So we're starting with an A, right, with a benchmark A that has a known elevation. We are transferring elevations as we go along, establishing those elevations, and we're coming back into A to make sure that we are within tolerance. The sound, right? Just that one, just as much as simplistic as I can put it, without being too confusing, because we will get into some nitty gritty stuff here in a second. All right. So let's go back. Let's backtrack to going through that. So you probably see this in lecture, but again, I'm going to show it to you right now, probably because you guys need to have somewhat of an idea of the theory of it, so that way you can actually practice it. Okay, so differential leveling. The purpose of leveling is to transfer elevation from one point to another. And in this visualization, we are looking at what we call a profile view. Everybody would know what the difference between a plan view and a profile view is? So a plan view is you're looking overhead, like kind of like what you do like with an aerial. You like overhead and you see the whole thing from the top of it, right? Kind of like what you do with like Google Maps, right? Google Maps, you're looking at the top from the top down. You're looking at the plan view, right? You look at a regular map, you look at the map of the United States, right? It's just you're looking at the top of it. You're looking at all 50 states sitting on top, right? Excuse me. Does anybody know what a profile view? Now that I say plan view, could everybody just kind of take an educated guess what a profile view is?
From the side.
From the side, right? And the same thing when you get your mugshot taken and they make you turn around and do this. This is your profile. It's kind of the same thing, right? You're looking at the top, you're not seeing the three-dimensional. This is what now is looking at the three-dimensional side of it with the profile view, okay? So as you can see here, what we do is this little guy is the instrument here. That's your instrument setups, okay? So it's essentially, you're just getting, this is just a summation of what they did. So they took measurements in between benchmark 35, this benchmark here, and this next benchmark that they set. And then they set another one, and they closed on another known benchmark. So this is benchmark 35, and this one is benchmark 36, okay? And what they did is they have a known elevation of benchmark 35, they have a known benchmark of benchmark 36 here. 35 and 36 are known elevations, and in between, they went through and established elevations for points 2, 3, and 4. Does that make sense? Right? They established those elevations based off of what we have our basic adding and subtracting, and I'll show you guys how we do that here in a second. And then they had 4 instrument setups. Do you see that? You have setup 1 on A, setup 2 is B, setup 3 is C, and setup 4 is D. Make sense? Those are 4 different setups. Okay? They went through, and again, they tried to get as equal distance as they could in between the 2 setups, or in between the 2 the elevations that they set up, so they can establish and they can go and close back into it. Okay? That's just kind of just a summation of what it looks like when they do this type of differential leveling. Can anybody take a guess of why we want to do differential leveling on like a construction job? You have to know elevations, right? If you have to build like a good one that we did this past 5 years is we worked on the Kingsley Field Air Force Base. Everybody familiar with the Kingsley Field Air Force Base? So let's go maps here. So we go and scroll, and again, this is a plan view now, right? Because we're overhead of it. You guys see all this concrete that's sitting there where the jets are? We had to replace all that concrete starting back in 2019. We did the survey back in 2018, and then we had it engineered. They went through the design process. They did all that stuff, and they said, all right, we got to demo all this concrete starting down here. Let me show up. Starting down here. Take this part out too, all this, take this part out too, take that part out too, and we have to replace it with new concrete. Okay? And the tolerances for that, all that concrete is 1/2 inch. The whole thing. Thousands of feet, you get 1/2 inch vertical tolerance. So what's the best thing to do? Well, when we establish benchmarks all around the perimeter of this thing, we also have to know that our horizontal is good, right? But we have to also know that vertical is even better because they're really going to watch that vertical. We're going to watch how make sure that those elevations are meeting specifications, so that way there's no issues with drainage, no issue with concrete being wrong, with the elevation being in different grade breaks, having those type of issues, right? So again, this was that project we started back in 2018, and we just finished it June of this year. So yeah, that's again an extreme version of why we do differential leveling, or not extreme, but a good example why we do it, because specifications like these projects, you have to have those known control, known benchmarks to come off of and establish meet those specifications. All right. So back to it. So tools that we use, automatic levels, which you guys will be doing today. Okay, that's what we'll be using for automatic levels. Digital levels is a different one. That's kind of used more in practice, especially when you do establishing levels, laser levels. That's what you guys see with kind of like the concrete guys or the excavator guys. That they got the little small tripod and you got the little laser and they got the little rod. That's the laser level. Total station. You guys will be using total stations when I get back in about 3 weeks. So we'll be doing that. And GPS, global positioning system. That's a different way. And that we'll also be using in about 4 or 5 weeks, if I remember correctly. So again, those are the different tools that we use. The most common ones for differential leveling are the first two. Total stations are another good one because the reason they're called as total station is because they can do everything. That's what the name total station comes behind it. So again, these are the examples. So again, on the top left, this guy here, that's the automatic level, which is something similar that you'll be using. We have these ones here, these little top guns that you guys will be using for the term. And then we have these GPS. I think we have a different style now, but we have these GPS down here that we also have for you guys available. And this one actually here is what we have in our office, this digital level that we use for like that Kings of Field based job. So anyways, those are the different types of examples. Okay. So the basic leveling procedure with the automatic level, and this is what we're going to be using today, is the general construction of the instrument, right? Procedure for the setup and transportation, ballasting, what we call the front sight, but I say foresight and back sight. Reading the rod, keeping the notes, calculating the class inaccuracy, and then the curvature and refraction. We won't worry about the curvature and refraction today. That would probably be taught in a theory for lecture. That has to do more with extreme distances, because I think anything past 500 feet to 600 feet is where you have to deal with that curvature and refraction. If you guys are flat earthers, I'm sorry, but that doesn't really exist. That's just, you guys just take it. So the setup instrument, we have the leveling screws. Okay, that's these little black knobs that you see right there pointing to them. Then you have what we call the round bubble level. Okay, that's how you're going to make sure that thing is leveled up. And again, we're going to walk through it all here in about 30-40 minutes. Reading the rod level. This is this on the bottom right, that bottom area here, that's going to be what you're going to be using, and it's just this big fiberglass rod that you extend, and it can extend up to 25 feet in the air. We're not going to use it. We don't need to go up that high. Usually just go up one, clicks in, and you're fine. But if you read it, you look at it. I don't know if I can zoom in. I'm going to try to zoom in here. I'll give you a better view at this thing because it's really tight. Okay, so we have what we call, let me go down here so we can see like the foot marker as well. So we have these little black thick marks, okay, and these are all measured in tenths of foot, okay. So that's established. Did you guys already establish from the beginning? We don't do inches here. Everything is in tenths of feet. We don't do 5/8, 3/8. We don't do any of that. We do 0.1, 0.15, everything like that, because it's easy across the board just to add and subtract those numbers, right? It's a tenth of a foot. I don't know why carpenters and all those guys still use inches, but because they just enjoy torturing themselves with fractions.
Well, you can easily do a third of a foot.
Right. It's just one of those things that we always constantly have to deal with a carpenter, and then we always have to convert it quickly in our head now, and just go back and forth, and they get really easy. So anyways, so we're going to be using these rods. And these rods, again, they stand, I would say, about 5 feet to now 5.5 feet without having to extend it. Okay. And so what we do is we use the automatic level and we use this rod. And the rod is how we establish these elevations. So when you're looking through the scope of an automatic level, you're looking at, you've seen the crosshairs. The crosshairs will usually line up, on one of these tick marks. And the way we read it is the big fat, I think it's in red, is the foot marker. So we have 5 foot, right? And then the way we establish whether it's 5.0 or 4.1 or 5.25 is by looking at the next set of numbers. So we have the foot marker, then we have the tenths, right here, and in between we have the hundredths. And how do we establish what is what on the hundredths? Well, so here at this top of this tick mark here, on this little spot, that's 5 foot even. The next tick mark up, that's 5.01. This guy here. Wow, doesn't write. No, I can't write. Cool. So that's going to be 5.01. So the easiest way to know that is the bottom tick marks are going to be odd. The top tick marks are going to be even. That makes sense? Right? So we count it. We go 5.01, 02, 03, 04, 05, 06, 07, 08, 09, 0.1. Right? That's how we establish it. And if you go up here, another example, I don't know how you can do 5.7666 because that's pretty crazy. Or 5 point to the naked eye, you can't do that. But another example would be if you're just in between, like let's say this number, like your crosshairs just fell in between. Well, I would just say that's 5.75. That makes sense? 5.755 instead of this 5.66, 7.66. Nobody can do that to the naked eye. That makes sense? When you're out there reading the rod, and the rod is 200 feet plus away from you, and you're trying to read it through this small scope, you're not going to be able to establish that it's 5.766, right? It's the thousandths with the naked eye. If you're getting in between 2 tick marks, you're just going to go, and you know that it's 5.7, and then you can't decide if it's 5.76 or 5.76 or 5.75. One of the two, just go 5.755, split the difference. Make sense? Go down to the thousandths, or go to the thousandths on that. All right. So, anyways, so that's how we read the standard level. The other portion of this standard level is when your rod man, the person holding that rod, is just standing there holding it on the benchmark. What they're doing is called just what we call just a slow wave. They're just holding it there, and they're just slowly rocking it back and forth while you don't have to do it the whole time. Just while your instrument person is reading the rod, you're just doing this slow wave back and forth. And the reason being is because you're going to see that the crosshairs hit the lowest point at some portion as the rod is waving and the crosshairs are coming out or the reading is coming out. It's hitting the lowest point of that rod, and that's the reading that you want to take. Does that make sense? The other portion that you need to understand, let me just get the paint out here. The other portion that you understand is when you're looking at this through the crosshairs, so let's say this circle is the scope. You're going to have your crosshairs coming through here, right? There's your main. You're going to have a top, and you're also going to have a bottom line. Those top and bottom lines are for what we call a 3-wire leveling. They're not for this class. So you just have to pay attention that you're not looking at this top crosshair or this bottom crosshair, and that you're looking at that main crosshair. That makes sense? So again, you're going to be looking through there, and you're going to be seeing this crosshair, and it's going to be as the rod man is waving that rod back and forth, you're going to be seeing where that crosshair gets the lowest reading on that rod. Okay? And again, it's kind of hard to visualize now, but when you actually see it in the field, you go, oh, okay, that's what he's talking about. So that's kind of the general idea of what we're going to be looking through when we're looking at that scope. Yeah?
And you read the lowest, right? Because that's when it's level.
Yeah, that's where it's level. Correct. All right. So the confusing way of how we set these up. So this is somewhat of a good example of how we keep our notes. So if you look at the differential leveling module or the lab itself, I gave you guys just a sheet that we started with, and we're going to using this sheet to fill in all the information. But the notes, what they don't reflect is that we need to skip a line. So this TP1 line right here needs to be here with this row A or benchmark A. We need to skip every other line. It makes sense? Because we need to reflect what we're doing in the field. So these notes, especially for the first time, they get a little confusing when you guys are looking at it this way. Because what we're looking for is kind of something, let me pull up the other one. Something like this one. Something like this. We have the notes, we have our known benchmark tip, and we have our readings that we're going through, and then we have it all skipped, and that way it makes a little bit more sense. Okay. So we're going to be looking at it in this fashion. This other note form was for back in, I think we changed the lab style back in like 2021, somewhere around there. But we used to have, everybody had their own individual field book, and this is how we would keep our notes in the field book, right? Today, especially because there's so many engineers, we just give you guys the handout. You guys just do it, and just upload it, and be done. Okay. So this is just kind of the similar. This is what you would be looking at when you'd be writing down the differential leveling notes. Again, this is where all the information would go on the left-hand side of the page. This is where all the checks would be when you're all done and finished, making sure you're within all the tolerances or making sure you're falling within one of the tolerances that there is. And then this is just kind of the description of where you're at, what you did, who was with you, what was the weather at the time, the dates, and then a small sketch at the bottom just to give you guys just a location sense or geographical sense of it. All right. So let's see, mesh closures. So mesh closures, I'm gonna leave that to be in lecture today. I'm just gonna go over what we're looking for. Okay. So again, there's these federal standards or these federal geodynamic standards, but there's also these other standards that we're going to be using that are just not as high as federal geodetic control committee, but they're within tolerance. Okay. So this is what we're going to be using. Is this what we call class 1, class 2, or class 3? Okay. So the minimum that we need to fall under is class 3. Okay. The class 3 is just the 99 where the 99% of you will fall, right? Is if there's something that went wrong with just one reading or missed 2 readings, you're still within that variance of being able to fall under class 3. Class 1 is everything went smooth, everything was awesome. You guys read every single point, you had every single reading on point, no mistakes, no screw ups, and you guys just came and closed, and you guys were 0, right? You started with the known elevation, you came back, you established all the elevations. You went back to the starting one, and you were 0 the entire way. That's class 1, right? You're perfect. So close the loop or close the level loop on the benchmark and check the closure of the loop. The level loop should be closed within 0.300ths. So that's class 3, 300ths of the square root of n, where n is the number of setups in the level loop. Again, how many times did you set up your instrument, right? So if you set up your instrument 4 times, that's the square root of 4 times first class 3 or class 3 minimum, see if you meet that. So that's 0.03 times the square root of 4. Make sense? And what would that be?
0.06.
0.06. Right. So again, you would have to make sure your mesh closure is at 0.06 or under or less than 0.06. That make sense? Okay. All right. So elevations, so datum stuff. Let's skip that for now. So these are benchmarks. So this is what we're going to be using on the top left there. We have a benchmark that looks exactly like that on the top left, and it's called benchmark Ager. Again, it's sitting right out here. Let's go back up to OIT. So we are sitting, somewhere right here in this classroom, down here south in this area. We have this little 3 red boulders that are right here in this little triangle piece of concrete. In the center of that, there's a benchmark that looks like this guy. There's a little steel lid. I think the lid might be broken, so you might have to play with it a little bit. you got to lift it, and there's a little steel pin that's sitting underneath that lid, just like this guy. You see that? I don't know if you can see that steel pin that's sitting right in there. That is an established benchmark that is accepted by the National Geodetic Committee here around, nationally, that we established quite some time ago. And so we have a known benchmark elevation, and that's what we're going to be coming off of. We're going to be coming off of benchmark Ager, and you're already given the known elevation, and then you're going to establish the other elevations around campus, and then you're going to come back and close on benchmark Ager. Okay? And if you guys look at the elevations here, or you look at the notes here, benchmark Ager, your starting elevation is at 4325.50. So, given that we said class 3, you have to be within 600ths, right? What would have to be, if just by doing quick math, plus or minus what for your elevation there? What would it just give you? Plus or minus 600ths, one way or the other? What is it? 0.4 to 0.56, right? That's where you have to be class 3. If you get anything under there, then you just keep going back. So again, if you get less than 600ths of a foot, well, did I meet class 2? Yeah. Did I meet class 1? Yeah. Cool. So again, the whole purpose of this differential leveling lab is to meet class 3. Okay. If you don't meet class 3, you have the option to redo the profile and library lab or get deducted points. Those are your true options. Okay. So benchmark, that's again National Geodetic Survey. This is our data sheet that we established from it. See drawings, profile leveling. We won't do it into that. It's another issue. That's for another time. Okay, so let's go back to the notes here. So that way we can start with this guy. So here is a nice little example that we have. Okay, so this is already given the rod reading. Okay, so this group went out. They used this benchmark tick with this known elevation, and then they established what we call the back sites and what we call the foresights. Okay, and the back sites and foresights. So let's go over those real quick, and then let's just clear this thing. Let's go file new. Don't save. Okay. So let's say we have I'm gonna erase for you, right? Okay. So we have Owens here, right? Owens Hall. We have benchmark Ager right here. And you guys can establish these. We're going to be using those little hubs that we set last time. That's how we're going to be using elevations or establishing our elevations. You can go around, establish those hubs. And let's say we got to establish at least 4 of them. And let's call them A, B, and C, and D. And let's go clockwise. Okay. So let's go. We got A here. We have C here. Or B there. We have C here. We have D. And then we're going to come back to Ager from there. Okay, so we're going to go from Ager, we're going to go to A, then to B, then to C, then to D, and then we're going to go close back on Ager. Okay. So just by looking at it, okay, we're going to have to go. One of the first things I would have to tell you guys is make sure you have line of sight, right? Make sure you can see. If you set up a hub here, make sure you can see Ager and A if you set up in between them. Okay? Because what you're doing is when you set up, you're setting in between the two benchmarks that you are using. Okay, so let's say we're coming off of these two, and this is you right here with your instrument. Okay, make sure you have line of sight going this way, and you have line of sight going this way. That makes sense? Because you're going to be reading that rod, so you need to know that you can see that location, that direction, and in this direction. Okay. So because we're using the known elevation of 4325.50, right? We know that is our established benchmark Ager. Okay. So the first thing that we're doing is we're taking a rod reading from benchmark Ager, right? And that is called what we call the backside. backside. And then we're taking a rod reading, and we're getting a rod reading for that benchmark, whatever it is. And then once we record that number into our notes, and then we take what we call the foresight, and that's the next reading here at A, and that's just the foresight. Okay? So if we look at our notes, that's here, and I'll put this on Canvas for you guys so you guys can look at it as well. So kind of the similar thing. Let's just say this is called. Let's just change it right now so you guys avoid confusion. Acre, right? And let's say again that's about 43.25. Okay. So again, you guys set up in between your 1 point and your next point, and then you get your what we call backside. And as you can see up here, we have this little plus and we have this little subtraction. Okay. And those are to kind of remind you what you have to do with that, with this number and this number in order to establish your elevations. All right. So what we do is we always add our backsides, okay, and we always subtract our foresights when we're running through this, jumping through these numbers. Okay. So the first thing we want to do is to establish the height of instrument at this setup. Right. We need to establish that height of instrument. What is HI? Okay, what is that height of instrument? Well, in order to establish that, we have to use the notes that the data that we collected. So in this case, we have that elevation of 43.25, and what measurement did we take first? We took the backside, right? That was the first measurement. That was the backside to A, right? We call that the backside. And what we have to do is add that. And so what we do is 43.25. 43.25. And we go plus our 3.47. Oh, it's not going to let me do it. Interesting. It doesn't let me do my formula in there. Anyways, so let me do it the other way. Let me do it here on the calculator. So we go 43.25.5 plus that 3.47, and I get 4328.97. It's not letting me.
I think the font is white in that section.
Oh, really? That's not cool. Where are you seeing that?
It says no, when first downloaded, highs and elevation numbers are in white font. Change from the black to see answers.
Huh. I feel like an old man right now. Oh, thank you. Let's do that for the whole thing. Oh, there we go. Okay. Let's delete these so we can walk through them. Okay. There we go. Anyways, so let's go back to the formula then. So we got 43.25, right? And then we have to add that backside. 347, 3.47. And we get 4328.97. So what does that mean? So that means the height of the elevation that when you set up, right, and you took your measurement, you got your measurement of that backside, you added it to your known elevation, and you got 4328.97. That is the height of your instrument. That makes sense? All right. Yeah. And then the next portion of that is you turn to get your foresight, okay? And now you have to go this number here, right? Subtracted by this foresight number. So that is 4328.97 minus 1.70. So what does that number tell you right there that you just calculated? What do you think that number tells you? Or what's that purpose of that number that we just calculated?
The elevation.
That's going to be your elevation of that A or TP1. That makes sense? You've just established that elevation right there. So by taking that measurement, right, by taking that reading of the backside from the known elevation, you establish your elevation of the height of instrument, and now taking that elevation or taking that rod reading of the foresight, subtracting it by your height of instrument, you just established the elevation of what we call that benchmark A, or in this note example, TP1, right? I mean, I can call it A, right? We call it A, right? That makes sense? That's all we're doing, okay? And now, what do you think the next step would be from there?
Moving between
You Jose, what you got?
You just go to the next one.
You go to the next one, right? And where are you going to set up for the next one? Just using this little guy right here. Between A and B, right? That's going to be, so that your next setup, right? This is setup 1. This is setup number 1, right? So where's setup number 2? Setup number 2. A. So what becomes the backside here? A, right? Why? Well, because you established that elevation, right? You just established that elevation to be whatever the heck we just came up with. 43, 27, 27, right? So this elevation here is 4327.27, right? We have established elevation there. So now we got to take another backside reading, right? Here. And we got to take another foresight reading here, right? We're tracking? Okay. So then, and again, I'm going to change this guy here. And then again, so now, because where am I going to write my HI in the next section here? Where would I write the HI calculated the elevation? J, A, and B. This is why we skip, right? To kind of reflect what we're doing in the field. This is why we're skipping the lines right now, just to reflect what we're doing in the field. Okay, so it's going to be here, right? And now, what 2 numbers or what 2 values am I going to use to establish my HI? Yeah, and that's going to be added to what? The previous elevation, right? Not the original elevation of acre. We just need to use the previous elevation that we just established of A. Make sense? So we need to use the previous elevation of 4327.27 added to that rod reading we just took from the backside of A. And now that is our new height of elevation, our setup number 2 height of instrument elevation, right? Tracking? Okay. And then pretty simple. What's the next step? Well, we got to establish the elevation of B since we took the rod reading of B, right? And again, that's just going to be that 4336, or sorry, 0.37, and then minus whatever that was, 1.06. Sorry, let's do that again. Minus 1.06. Okay, and that is now the height of B. Yeah, make sense? All right. So now let's, to skip all this, let's say we get down, right? And we get down here and we close our elevation and we're at that 43.42. That's our mist closure, right? That's the mist closure when we get back to, actually, let me put here. That's the mist closure, 4325.42. Okay. So what was the mist closure between our starting and ending? What's the delta there? 0.08, right? So not so great, not so bad, right? So how do we figure out if we're within tolerance? Okay. Well, we just got to use the number of setups that we did. So we have 1, 2, 3, 4, 5, 6 setups, right? Right. So that's n. So the square root of n times that first constant of 0.03 is going to see if we meet that tolerance, right? So again, if we do that, square root it in here. Anybody got a calculator on it? This one doesn't have it. I can't do math in my head.
Root 6.
Yeah, square root of 6 times 0.03.
0.073.
Say it again.
0.073.
0.073. All right. So did we meet it? No, right? We're 0.08, right? So that's the issues that are going to come up. You're within 100. You're out of tolerance by 100, but you're still out of tolerance. Do you go back, right? Or do you take your points and deduct and just take the deduction? Your choice, right there. Okay, that's your choice. But now let's say we close and we're 3, 4, 5, right? 500s. We're within 500s of what we misclosed or what we started with. Are we within tolerance? Yeah, right. That's within tolerance. Okay, so that portion is what we meet class 3. Now you can go and see if you meet class 2, right? So again, the minimum is class 3. Now you just go up and see if you can meet class 2 or class 1. That makes sense? Okay. And then the other way you can check yourself or establish and make sure you're good here is you're going to take the summation of your backsides. Let's see. It's also there we go. You take the summation of your foresights, right? And you get, let's say, this one, yeah, that's going to work out. That's going to work out right there. Anyways, let's take the summation of your backsides and the summation of your foresights, and you're going to take the deltas in between them. And what do you get there? What if you take the summation of your backsides, summation of your foresights, and you subtract it? What's that value? What's that delta right there? 0.05, right? And that should check with the misclosure deltas between your starting and ending. That's 2 checks that you can do. Make sure that your math is correct, right? Especially if you closed and you were 0.08 delta, right? And you go, okay, well, let me just make sure that if I add up all my backsides, I add up all my foresights, and I take the deltas of those 2 summations, they have to be the same as the delta between my misclosure of my starting and ending benchmarks. That make sense? They have to be the same. Okay? Now, this part is the tricky part, is the adjustment part. Okay? The adjustment part is something that takes a second for kids to get their head wrapped around on. But it's this right here. This is the other example that I have. So again, this is another one. So again, let's say that you ran through it all, right? And your misclosure was 500s again, okay? And then again, you took the summation of the foresights and backsides, and then you did that, and you got 500s, okay? So then you take that misclosure of 500s, and you're going to go divided by the number of setups, which was 6, okay? So you're going to go your 500s divided by 6, and you're going to get your 0.008, so 8 thousandths of a foot per setup, right? That's what you're going to use. And again, if the error is high, you're going to add. If the error is low, you're going to, let me say that again. If the error is high, you're going to subtract. And if the error is low, you're going to add. Make sense? So again, in this case, they started with 87.22. They ended at 87.27. Were they high or low? They were high, right? So what do they got to do? They got to subtract, right, on their adjustments. So what they do is they're going to multiply correction at each setup by the number of setups being adjusted. So at the correction of turning point 1 or A, you go your established elevation, so that's 88.99 time or subtracted by, because again you're subtracting because you were high, your 8 thousandths times the first setup, which was 1. Okay, that was setup number 1. So that's just going to be the same value, right, of 98. Or sorry, that's just going to be your 0.888 or your 88.99 subtracted by 8 thousandths, right? And that's just going to be the new adjusted elevation is going to be 88.98. What about setup number 2? What's that going to look like? Well, it's right here. It's going to be your established elevation of 97.03 subtracted by that resulting dividing error, right, of 8 thousandths times setup number 2, because it's number 2, so it's, or times 2 because it's setup number 2. And again, that value, that new adjusted value is now 97.01. So again, as you can see here, this is the new adjusted elevation. As you go down the line, your new adjusted elevations now meet or go to 0, right? When you adjust every single one. Again, I'm going to put this on canvas for you guys so you guys can take a look at it and have it as an example. And then that way you guys can understand what we're looking for on the adjusted value. Okay? Any questions so far? Nothing? So I think the sun has come up a little bit, so we can actually go outside and work with these instruments. So just let's go over the lab one more time. So there's going to be a separate part to the lab too. And what we have is called the peg test. It's a calibration, okay? So the peg test is essentially making sure that the instrument works. Okay, so let me do a new one here. Don't say it. So the peg test is we're going to use just a flat area. We use the sidewalks all around Owens. We use that driveway that goes in between Seaman Hall and Dow and us. Or actually up here on the front by the LRC, that big concrete sidewalk. We just need something flat, is what I want. So essentially what the peg test is setting up, finding a location, or having the instrument set up, and we need to have total length. Let me go over that one more time to make sure I'm telling you guys correctly. Yeah, total length 200 feet apart. Okay, so again, we have A here, right? We have B here. The total length is 200 feet, approximately. It doesn't have to be perfect. And how can you guys do that? Just approximation, pacing, right? You just figured it out last week. You figured out how you can pace, right? 200 feet and approximately, equal distance. Yeah. So what you're going to do is you're going to have that rod reading, or that rod on A, and then you'll have a rod on B. Okay. You're going to take your reading and get whatever, and then take your next reading and get whatever that number is. Okay. So you'll record those numbers here. So let's again set up the level midway between A and B, and this is going to be C. Your instrument will be C. Read and record the level rod reading at A and B. Record those values in the table below. Determine the elevation difference between the 2 points by subtracting the rod readings. All right. So that's here. So again, instrument is at C, and let's say your rod reading here is, I don't know. Let me get the other sheet going on. Cool. So again, you get here, and let's say it's 50, right? And then this reading is 60. So again, you took your reading here, and that was 5 feet, right? And you took your reading here. And that was 6 feet, right? So what's the delta between the two? 1 foot, right? So your delta here, delta 1 is 1 foot, all right? And then this was C. And then let's see, come down here again. And again, A is going to be in the same location. You're not moving A, and you're not moving B, okay? Those stay in the same location. What does move is your instrument, okay? And again, you're going to move that closer to B, I believe. Let's double check that. So then you're going to set up the level, Readjust. Yes. So further instrument point. Wait, where is it? Okay, so the point is just further. Wait. Oh, yeah, there it is. Sorry. You're gonna pick up your instrument and you're gonna establish it closer to D or sorry, B, and that's gonna be your instrument now is gonna be. So again, you'll pick up. You'll come up here. Oh. All right, so that's D now, right? And again, you're gonna take your readings, right? And let's say you got your rod reading of 7 feet here, and over here was 6.9. Okay, or sorry, no, it's not gonna work. Sorry. Let's go to 5.99. Okay, you got 5.99. So what's the delta between those two? 1.01, right? So delta 2 is 1.01 feet. So now, in order to see if your instrument is calibrating, you're going to take the delta of the two deltas, okay? And you should be within 200ths of a foot, right? So you should be within 200ths of a foot. 200ths of a foot, right? And if we take the deltas of these two, and we just get the absolute value, what is that? We just take this minus that. 0.01, right? So are we within tolerance? Yeah. So that means that our automatic level is calibrated and good to go. Make sense? So that's going to be the first step. Is the peg test. You're going to make sure that your instrument is calibrated, right? Once you establish that your instrument is calibrated, you guys can grab your stuff, or start establishing your A, B, and C, or your 1, 2, 3, however you want to name your hubs, your control points, and you can start the differential leveling process. Make sense? All right. So let's go make sure we are on the same page. So again, for the equipment, you're gonna need the automatic level and the tripod. The hand level, not so much. It's the rod level or the rod level. Sorry, the hand level is what you. Sorry, I'm getting myself confused. You'll need the first three things are automatic level, tripod, and level rod. Those are the three things that you'll need for sure. Okay. The railroad spike, I wouldn't really use it. Definitely a calculator and obviously something to write your notes with, whether it's you're going to write it on an iPad or you're going to write it, physically on a notebook, something to write with. Okay. And then I should change it. It should just be, I push it on there. It's just hubs because we're going to set hubs and a hammer. You'll need hubs and a hammer. All right. So let me actually throw that in there right now and I'll throw that in. And let's say 4, right? 4 of them. We're gonna need 4 of those, and I'll redo this guy. So again, for sure, automatic level, tripod, level rod, and then you'll need a hammer and 4 hubs to establish your 4 control points. Okay. Out of that you're gonna do the peg test. That's the first step. Make sure it's all calibrated. The next thing you're gonna do is run your differential leveling around those sites, and then close back onto Ager. That makes sense. And again, we'll go through a quick tutorial how to use the automatic level, how to use the tripod legs, what I'm looking for, and just kind of how to just do the basic steps through this course. Okay. Any questions so far? All right, guys. Like I said, we'll check it. We'll check everything. Make sure you rotate your party chief or crew chief. Drawing a blank here. Oh, again, if you need to put anything away, you can stow it away in that equipment room. We want to keep it here. That's fine. I think they keep this door unlocked for sure. But that door will stay, it just stays cracked open, but you can throw anything you want in there. There's, again, if you're using handwritten notes, like if you're going to do handwritten notes, you can establish it by that way. We got clipboards back there. Make sure you got a pencil on you. And I would suggest maybe just taking a calculator and just kind of calculating as you go. Make sure you're staying on track. Make sure you're going to close within tolerance. Some guys like to just do it all, and then if they find out they don't close, they know how to do the steps real quick, and they can do it, in 20 minutes or less. It just depends on the group. Okay, you guys can calculate as you go, or you can just do it all and come back inside the office and calculate it while you're inside. And then again, the biggest factor is the weather, right? If it's raining and miserable, you guys just want to get it done fast. You get inside. If it's nice, and I think it's gonna be nice and sunny right now, it's just gonna be cold. It's a little bit more tolerable just to sit outside and go through the calculations. All right. So again, get with your group. Meet you guys at 203, and we'll get you guys equipment checked out.